Hello there, I'm Thomas Hatsios, the British-American pilot flying the Boeing 787-989 flight from Zurich International Airport. We're gonna be overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport 114 for an Lszh localizer landings. Right now in the cockpit for the pre-takeoff preparation of the quality with 787-900 model. You can see the 787, the Boeing model. New one, so you can see the cockpit all over. So I'm gonna make an explanation of the systems of the 787-900, which are identical to the Boeing 777-300 and 200. Then I'm gonna show you the overhead panel. I'm gonna show you the primary flight display that displays the airspeed indicator, the ground speed, the airspeed selected from the autopilot flight director system panel. The barometric altitude above the sea level, the barometric altitude selected, the barometric pressure of the outside atmosphere, the altitude selected from the autopilot flight director system panel, the altitude indicator of the pitch ladder decrease and bank angle decrease, the Lszh localizer, the flight director crossbars, and the autopilot crossbars for automatic guidance of the aircraft. We have also the magnetic heading and track, the magnetic north pole and south pole, and magnetic variation depending on where we are in the world, as you can see. So we have also maybe some other functions. You can see maybe this one here will give us a bit more of the light we need here. So you can see here the primary flight display that displays all the things, the navigation display, the ACAS. So we have the navigation display. The navigation display displays the airports, the waypoints, the nav aids, the terrain and weather reflection from a weather radar, other aircraft that fly around our own aircraft, the distance they are located, the altitude difference, the direction and the warnings using the TICA system, the transponder traffic collision and alert system, and the transponder, the DSP and ATC transmitter receiver transmits our own frequency to other aircraft and air traffic control, and receives from other aircraft and air traffic control. We have also the navigation display, the vertical deviation. You can see the vertical deviation of the aircraft in the air as it flies. Over here you can see the waypoints we have to climb or descend. You're gonna see the flight plan we're gonna follow, create here in the flight management computer. We're gonna use the flight management computer to create a flight plan. We're gonna input all the data of the aircraft, like the gross weight, that includes the empty weight, plus the passenger, plus the cargo, plus the taxi fuel, plus the reserve fuel, plus the trip fuel. So we have the takeoff weight of the aircraft, and we're gonna use the flaps for takeoff. This is gonna give us in the flight management computer the center of gravity, using the mean aerodynamic chord position, the Mach that is included in the chord of the forward wings, the chord of the forward wings. But it should be like 25-26% for this weight, because we're gonna use 30% of fuel on board. You're gonna see perhaps we have only the left and the right wing fuel tanks over here. I'm gonna show you also that. So also the exterior of the aircraft over here. So you're gonna see also the flight management computer, the panels here. You can see the primary flight display, the waypoints here, and the airports. We're gonna create a flight plan. So I'm gonna use the flight management computer to input all the data of the aircraft. As I told you, we're gonna select the departure runway. We're gonna use the flaps for takeoff, the gross weight of the takeoff, the mean aerodynamic chord position through the center of gravity, and the horizontal. This is gonna give us, using the flight management computer, the horizontal tail trim stabilizer position for takeoff. Then for climb, cruise, approach, descent, and landing. So we're gonna have during the whole flight the horizontal trim stabilizer, either automatically set or manually, using the trim tab over here. You can see we can trim up and down. The horizontal trim stabilizer Over here, this is for the horizontal tail of the aircraft. You can trim up and down, and you can see the degrees in the Boeing 777 somewhere. Here, maybe here you can see it in the info, CDU, systems. So we have the systems, the flight controls. I'm gonna see here the elevator, the position of the elevator. So you can see we use this to move around the flight controls like this, and you can see the flight controls are moving, having the display of the systems display. You can see the wings, the tail over here, and the trim stabilizer. So we have the trim stabilizer up 4.49 degrees. It's automatic status. I'm gonna use again the navigation display like this with all the systems. I'm gonna use a flight plan. I'm gonna create a flight plan using the flight management computer. You're gonna see, I'm gonna select the takeoff, airport, the departure, runway. I'm gonna select the runway data using the flight management computer data using the flight management computer. It's gonna give us the runway length, the runway slope, the conditions of the runway, if the size dry or wet. We're gonna select also the temperature, the barometric pressure and density, and wind direction and speed. We're gonna have the takeoff speeds using the flaps and the horizontal trim stabilizer. We're gonna have the V1, V rotate, and V2, which is the takeoff speed. You're gonna see displayed in the primary flight display using the flight management computer. So we're gonna have also here. So we're gonna have here the CDU also displayed like this. I'm gonna have all the systems. So I'm gonna set then a flight plan using the flight management computers. You can see the flight management computer here, the left and the right. We can set a flight plan. We're gonna select the departure, airport, and runway. We're gonna use the seats, the solar instrument departures for the airport. That includes later on vertical navigation fixes. You're gonna see the flight plan created. We're gonna have the vertical and later on navigation fixes for the departure, then for climb, then for cruise. We're gonna have intermediate waypoints and fixes, then approach and descent. We're gonna have also the stars, the southern terminal arrival for the destination runway here. That is the same like the departure on the runway 14 in the Zurich International Airport. Then I'm gonna show you the autopilot and flight director system panel, the autopilot engage and disengage switch, the auto throttle engage and left and right engage and disengage switch, the flight director engage and disengage switch. We have the airspeed select. No, all the systems are the same with the Boeing 777 300. If you have seen my video, so we can have the airspeed select. This is gonna give us a commanded thrust rating to the engines. FADECs. The FADECs are the full authority electronic control computers. Gonna see them how they work. They are commanded by the engines, by the auto throttle and the flight director and the autopilot. You're gonna see the rating in the navigation display. The upper ACAS engine indication equivalent system display is gonna give us the rotation speed or the engine power rating of the low and the high speed starter and the low and the high pressure turbines, the N1 and the N2, which is the low speed starter and soft the N1, the low pressure compressor, and the N2 is the high speed starter and soft and high pressure compressor of the turbofan turbocharged engine. We have I think we have the G and X engines, but I'm not sure of the Honeywell. Maybe, I'm not sure. So we have also because this Boeing 777 is a little bit different from the 787 is different from the 777, so you're gonna see all the systems here. So I'm gonna show you the autopilot flight director system panel. You can see the airspeed guidance. As I told you, you can set an airspeed. This is gonna command the thrust by the engines if we climb or descend. It's gonna give us a fixed thrust for the climb or the descent on idle thrust, which is also fixed thrust. And the airspeed is gonna be adjusted by varying how fast the aircraft climbs or descends. The rate of climb and descent of the aircraft is 1,000 feet per minute, or the trigonometric angle and decrease the steepness of the trigonometric angle in degrees you can climb or descend. Also you can see I hope you like this view of the cockpit. I'm gonna show you also the bank angle limit, the heading select knob, the heading hold switch, the vertical rate of climb and descent of the aircraft, that's 100,000 feet per minute, and the hold switch for the vertical speed or the flight path angle that determines the trigonometric angle in degrees the jet aircraft can climb and descend. Also the altitude select knob and the altitude hold switch, and the bore localizer and the ILS localizer for the Boeing 787 for the autoland function. And then I'm going to show you the thrust levers, how they are interconnected with the auto throttle here. You can see you can move the thrust levers. You will see the engines power up. You will see also the warnings. So I'm gonna make also an engine start demonstration. You can see the thrust lever position here, forward and aft. I'm gonna show you many functions of the 787. So that may include also the navigation display here, the fuel on board. You can see some information that we have the left and the right wing, total fuel, gross weight, fuel temperature. So you're gonna see all this data. You're gonna see the autopilot here in flight director system panel, the thrust levers. I'm gonna show you also the overhead panel, which is identical to this 777. You're gonna see the left and the right engine IDG, the great drive generator would produce alternate current 120 to 100 volts for 100 Hz frequency, 120,000 watts either left and right engine. The backup generator, the APU, we need the APU to start the engines, the battery over here. The primary flight control computers, the IRS system, the heading reference and the inertial reference system controls. Here we have some additional switches, flight control surfaces. So we have also the passenger oxygen, the window heat, the rammer turbine hydraulic system, the left and right engine hydraulic pumps, the lighting system of the aircraft and the windshield wipers, the electronic engine control. We have the cargo fire and the APU fire over here. You can see the left and the right engine integrate the auto start system, and the fuel jettison. We can dump some fuel from the aircraft as we fly to lose some weight. The fuel tank, the left and the right fuel tank, the center tank over here is empty. So you can see the fuel tanks like this. We have the crossfeed on right now, and the center pumps, also center fuel bolster pumps, the hydraulic tanks like this, left and right engine. We have the cabin pressurization over here system. You have it in the auto, we can use manual. You will see we need to use the outflow valves, close and open when we descend, and select the landing altitude. We have the left and the right engine pressurizer for cabin pressurization, wing and engine at the eyes. Over here air conditioning, ventilation, and also hydraulic fluid here pressurization. We need hydraulic fluid for many systems, so maybe maybe I'm gonna make the engine start demonstration and set up the flight plan right now. So you're gonna see the engine start demonstration. I'm gonna come to the flight controls here. I'll first show you the flight controls, how to control the flight controls using the side stick. Use to control the horizontal tail, to climb and descend, to bang roll left and right, and also to use the rudder pedals for the vertical rudder and the nose wheel steering. So you can see here a beautiful view of the cockpit of the Boeing 787. So you can see here we have the flight controls. So we can use here the side stick, just like in the 777. So you're gonna see now the side stick movement. So you can climb like this. So you can climb, you can descend like this. You can make turns in the air. So I use this side stick. You can see the side stick deflection is proportional to the yoke deflection when I climb. Also when I descend, when I make turns left and right like this. So you can see the side stick deflection is proportional over here to the yoke. You can see also the outside view. So you can see the side stick deflection is proportional to the yoke deflection. Both control yokes, the left and the right, are synchronized. They move simultaneously, as you can see, when we are in flight. Also left turn, right turn, like this. We have the nose wheel steering also here, and also we use here we have the thrust lever control. So we can control the thrust levers forward and after. Maybe we can use also a little bit more light. Maybe a little bit more light like this. We'll have a better view of the side stick function. So you can see you can make climb and descend, bang roll left, bang roll right, the horizontal trim stabilizer, like this. Also the thrust levers while we're flying. You can see we set all the thrust levers happening. Increase and decrease. So it's a good thing to have the thrust levers. So now I'm gonna show you the outside view of the Boeing 787, how to use the flight controls again of the Boeing 787 using the side stick. You're gonna see all the surfaces, like when I climb the aircraft here using the side stick, or when I make turns like this. So you can see the side stick deflection is proportional to the yoke. Now I'm gonna show you the outside view of the Boeing 787. You're gonna see the wings here. You're gonna see the movement, the free movement of the wings. So you're gonna have here the wings moving, like the horizontal tail, the elevator, the ailerons and the spoilers, and the vertical stabilizer, the rudder. So we're gonna climb like this, descend, bungle left and bungle right. So climb, descend, make turns to the left like this, maybe make turns out to the right, also climb, descend, and you can see the vertical the rudder over here. So now we come inside for the engine start demonstration. I'm gonna show you the engine start demonstration. I'm gonna set up the flight management computer and make also the overhead panel, some explanation, and make the complete flight from takeoff, climb, cruise, descent, approach, and landing. So thank you very much again for joining me in this video. So I'm gonna start now with the systems. So you can see here the 787, the full view of the Boeing 787. So you have also electronic flight bag. We have also the airspeed here indicated, the airspeed selected from the autopilot flight director system panel, the barometric altitude above the sea level, the altitude selected from the autopilot flight director system panel. So all the values here are the same, all the systems like the 777. Also the engines here you can see. So we can make now engine start demonstration. We can set up here the overhead panel. We have the auto throttle here, left and right, the flight director, flight level change. We can set the airspeed like this. So we have to disarm now on this, the auto throttle. The heading, we're gonna use the heading for the runway we select. The altitude here. The vertical speed, light path angle. So we can use it at 0 now. Over here, 0 altitude, you're gonna see the thrust levers, you're gonna see this, which is the disconnect for the horizontal trim stabilizer. You have the fire extinguishers also. So the horizontal trim stabilizer, we need the autopilot disconnect also. Some systems you're gonna see now, like the engines function. We have the CDU systems. So CDU both here and here. We have the status. You can see the hydraulic, the APU, the oxygen level, and also the electric, the left and the right engine. Electric here, as you can see. The APU generator, forward, aft. The hydraulic system, left engine and right engine. Also the C1 and C2 is the same like the Boeing 777. The electric is pretty much the same. You can see the main battery here, the voltage. Also the fuel on board. You can see the left and the right wing, the crossfeed valve on the center tank, how much fuel we have in each tank. We have total 55,800 pounds. The low and the high pressure fuel valve over here. So you can see the hydraulic over here, the fuel pump, the electric, and you can see all the systems displayed here in this display that we have here. The air system, so we have the crossfeed valve, the APU. We're gonna turn the APU now on to make the engine start demonstration. We have the flight control computers also besides the electric system. So I hope you like it here, this view. So we have so we're gonna have here now the display of the air system. You can see the pressurizer here. When we increase the thrust from the engines, you will see more pressurizer over here. Fuel flow, oil pressure, exhaust gas temperature, and one fuel flow, oil pressure, temperature, quantity, and the vibration. And you can see the pressurizer somewhere here. The doors, the status, good cooling, the landing gear. You can see the temperature of the brakes and the pressure of the tires, the flight controls, the FS display, many systems, the maintenance, the circuit breakers. So we have the flight controls, which is the last system. You can see also the horizontal tail trim stabilizer position here. So we're gonna use also the lighting here, a little bit more light. So we're gonna have a few more lights on now for a better view inside the cockpit. So you can see the flight controls again, movement over here. Everything is working fine. There is no failure as we move the flight controls. The rudder, the vertical tail. So I'm gonna proceed now to the engine start. The checklist. We have also checklist, normal menu, just like in the 777. No normal resets. Communication. Air traffic control communication. Navigation display. So we have over here we're gonna set the flight one. So now I'm gonna show you also a little bit more on the systems here. The overhead panel. I show you the APU. We need to start like this. The hydraulic here and here, the fuel, left and right engine. So this is the overhead panel with the main view. The pressurizer, the fuel tanks, and the fuel jettison. We need the auto start on for either engine, like this. So we're gonna turn off both engines. You're gonna see the fuel control here off for the left and the right engine, and we have the engine shut down now. You can see both engines, right and left, turn off. So we're gonna have the APU on. In the start, we're gonna use the auto start on. We're gonna need to set one fuel control to the on. So we have the auto start now on. Over here you can see the left is on. So we have the systems now are off. We have the electric, I believe, back on. So we're gonna start. Left pack and right pack is gonna be automatically set for start. It will take maybe a minute, and we need to reset the auto start again one more time. So now we have it. We have the auto start on. You can see the auto start of the engines. Engines shut down, and we have one engine on. The left engine and the right engine is off, as you can see in here. So we have to go now for the right wing engine, like this. Engine auto start, and turn on the fuel flow. So we're gonna have now both engines. You can see in the right wing engine on. And here we have it, both engines on. We can proceed now with the flight plan and proceed for the flight. So create a flight plan, same like in the 777. So initialize 0 fuel weight, gross weight, index, position, reference airport, Lszh. So we have the position, performance, reserve fuel 5%, cruising altitude. So we have the performance initialized, cruising altitude, the route, departure. Copy paste this airport here. And copy paste again here. On the other side, Lszh runway 14 with departure. I'm gonna use now departure. You're gonna see here departure 14 and arrival. Transnegria and Summit. So we have the route here, the legs of the route complete. We can use also here the previous page. You can see all the buttons are the same. So we have the next page here. Perhaps we have a discontinuity. We don't have it. I don't see anything like discontinuity. So we can see also in this map the waypoints. We have also the terrain maybe. So we have the terrain also here and here. The map. So we can use the map like this. And we have only the last page, the systems info, fix legs, alternate the VNAV for the climb, MC communications. So we go in the index and we have the performance for takeoff. Over here we're gonna use all the flaps 1.5, and we have center of gravity also automatic 5 degrees, and the V1 we rotate and V2. So we have here the flight plan, and we are ready for advanced thrust levers like this. Parking brakes off, and I believe we are ready for takeoff here. So we're gonna have to taxi into the runway. We take the runway clearance over here. So you can see here we use also this for nose steering. So we have idle for us. The runway is open for us right now for the takeoff. So we have the parking brakes again. We're gonna use an airspeed for after takeoff here. So we're gonna have the flaps also set here. You can see the flaps moving. Here are the flaps for takeoff. Gonna use 15 degrees of flaps. The horizontal trim is automatic, so we're gonna use this up to save some frames from the computer. So I believe we are ready here for takeoff. The Boeing 787. So we are ready for departure. Parking brakes up and down. Disconnect. Advance the thrust levers. We have the thrust. So we have 90 knots, 100 knots, 115, 35, V1, V rotate, and V2, and here we go. As you can see, keep climbing. So we have positive rate of climb. We tracked the landing gear. You can see here we are 1,200 feet, 1,400 above the ground level. Keep climbing. 1,800, 2,000 feet, 2,200 above the ground, but 4,000 feet above the sea level. The airspeed here, you can see the rate of climb, the stall speed. We also have all the information we need. So we're gonna use more airspeed now for the climb. You can see also the initial climb, the path here where we need to climb to, and start making perhaps the turn now. So you can see we use this to control the aircraft, and the rudder pedals to make the turn. You can see the stall speed and the airspeed right now, 151 knots. We crossed 8,000 feet, and we need to cross over here this waypoint, the legs. Activate and execute. So now we have the active the flight plan here. It says pink, as you can see. So we're gonna set all these things for the initial climb. So we keep turning. So we need this, the first one, waypoint here. We're gonna have it. You can see the distance. We are from the waypoints as we keep climbing. So this is the Boeing 787, the 900 model. Keep climbing. About now 12,000 feet. The airspeed is 166 knots. We have this beautiful sky right now, and the star sign here. A lot of star sign, frozen skies, and this beautiful purple colors in the sky with the blue. So we cruise right now with 162 nautical miles per hour. So perhaps maybe gonna have also the view of the aircraft. This is the 787. You can see also the Switzerland here, the Zurich, a beautiful view. So we need also perhaps to accelerate. We have 100% right now, 102 for the engines thrust. So we have to make it through this waypoint, then follow the next one. So we have to follow these waypoints here. As you can see, we have to go through this line, go over here, and then come back for the landing. Make a turn. So we climb 17,400 feet right now. This is not as fast in climb like the 787 is much like the 777 is much faster when it climbs. The climb rate of the 777. So the same way. So we have here. Maybe retract some flaps now and level off for Y to increase the airspeed. Our airspeed component needs to increase, so we need to level off. And connect also the autopilot to see how it works. Across 20,000 feet, we need to stay in the line here. As you can see, we have a good follow-up of the flight one right now. I haven't reached yet the cruise altitude, so maybe pull up a little bit more. So you can see how small it is compared to the 777 when we look over it from this view. We haven't reached yet the altitude. We have the chemtrails and the contrails, but we have a beautiful view here of the Lake the Zurich, the Germany, the Bayern Munich in front of us, the France on this side, and the Switzerland, and we have also the galaxy here, beautiful galaxy. So maybe when we cross like 30,000 feet, maybe 28, we're gonna have the frozen vapors, the chemtrails. So we are 25,000 feet. The cruise altitude, we need to level off here pretty much. So we have the Germany in front of us. We can keep going to track the waypoints here. As you can see, we have a good level off here for the first waypoint, and then we make a turn back to the airport. So maybe we have to climb like higher, like 27,000 feet to see the chemtrail. So maybe we climb like 27,000 feet. We're gonna have the chemtrails, so we can start climb. Six 6,927. I need to climb maybe even higher, like 29,000 feet. So we're gonna climb even higher, 39,000 feet right now. So we're making now the turn back for the airport as we cruise here. Maybe we'll keep climbing, not cruise yet. So we're gonna increase us the airspeed here requested. So here we are. So now we have the chemtrails, I believe. Here we are. Here they are, the chemtrails, and we have a little bit of luriness now. Blur view. So now we clear it up. We have the chemtrails, as you can see. The frozen vapors of the Boeing 787 as we cruise to 88,500 feet, and we're going back to our airport right now. So here there are the chemtrails, as you can see. You can see we are 28,400 feet over here. We have to cross the lake again. So now maybe we cruise with 900 kilometers an hour, 300 meters per second. Need to climb a little bit higher. You can also connect the autopilot to show you. So we have to level off. 29,400 feet, and we have to fly straight. We can use the autopilot on now. So we have the autopilot connected now with the Boeing 787. So this is gonna help us a little to set up the approach here, as you can see. So we're gonna have to fly now straight to the next waypoint over here, and then start descent. As you can see, so now we cruise with the autopilot on in the Boeing 787, and we are having the frozen vapor. So this is our spacecraft for tonight, the Boeing 787, 900 kilometers an hour, 300 meters per second over Switzerland here. So we have also the autopilot on the 787. So now we going back. Perhaps we have an airspeed warning to decrease the airspeed. Also, we need to start the descent. Select a lower altitude. So you can see the setup of the autopilot now with the 787 as we are descending with the autopilot on. You can see also the information here. We have the LNAV and the vertical speed now. So we need to slow down the aircraft and set minus. So this is gonna give us the vertical rate of descent, like this. We need to slow down also. So we have Mach 0.627, about 700 kilometers an hour our airspeed right now, and we descend back to the airport, as you can see. So we have some overspeed warning again. So we disconnect the autopilot now. So we keep the setting. I'm gonna have also the Lszh localizer for the Lszh here. So we have to connect now the altitude, and this is gonna give us the descent rate here. So we are here descending to the airport. You can also use the roar localizer to aid us for approach here. So maybe we have to use some flaps also now. Start using some flaps. So we have to align now with the Lszh localizer as we descend. To 9,800 feet. Eight thousand feet. Keep descending. Now 8,000 feet, and we are much closer to the runway. As you can see, we are aligned with the Lszh localizer rules. So we are coming now for descent, and we're gonna have a nicer view like this, I believe, for the touchdown of the aircraft. So we're gonna use also full flaps perhaps. So you can see we are descending now. We have the Lszh localizer also. We are fully aligned with that, with the Lszh localizer and the glide slope. So we can also use the outside reference over here as we descend. You can see the navigation display in here. The airspeed, what we need, the manual airspeed and automatic, both together. So we are almost 1 minute. You can see manual rudder pedals here and thrust levers. We have a little bit more thrust automatic now. We need to descend a little bit further. We have some side wind, it pushes on the side as you can see. So idle thrust now. Here we are. Parking brakes and reverse thrust, full reverse thrust, as you can see. So we have full reverse. Full reverse, and we are slowing down 70 knots. As you can see, we made a nice landing over here with the Boeing 787. We can exit on the runway. So you can see we have everything here. The nose wheel is perfectly safe. There is no breakages of the nose wheel or the behind the wheels here. After the touchdown, we made also this side. You can see all the wheels left and right, and the forward the nose wheel over here is perfectly normal. There is no breakages. You can see all the wheels. The aircraft is starting up the way it should be. We have the autopilot disconnect warning right now. You can see the nose wheel is very nice here looking. Also nicer view around where we are right now. So now we have we can disarm the thrust or reverse like this if you need. So everything is fine. Inside the aircraft, all the systems, the overhead panel we still have. This warning here is the autopilot disconnect. That sounds maybe brake temperature, so we cancel that. So hope you like the inside. So that was Thomas Hatsios, the German-American pilot flying the Boeing 787-900 nice flight from Zurich International Airport to Zurich International Airport. Just landed. We complete the whole flight. Thank you very much for watching. See you next time. Bye bye.